Okie doke. Let's get it going. Okay. Alright, so before we were talking about, the two potential issues of using unsigned variables in array loops. The problem, because the index is an unsigned value, we have to either create an unsigned value and use it to index, or we have to convert a signed value to an unsigned value, either to a standard size t or an unsigned int, but probably a standard size t. The issues here that if we're decrementing a loop, a loop variable in a loop, so we count down, we can't count down for, we're going to count down forever if we use an unsigned int. The reason why is because once we hit 0 and we decrement again, we get not -1, but actually underflow. We loop all the way back down and get the highest value that it could be, so this will happen infinitely. So one, the loop won't behave as expected. So that's unexpected behavior, but not undefined behavior. But in doing so, because that loop counter variable is also our index, we're also going to be indexing the vector, a standard vector in this case, but the array. We're going to be indexing the array out of bounds, meaning that we're going to be passing, or we're going to be subscripting it with an index that it doesn't actually hold unless you happen to create a vector with direct initialization and you pass it a standard, or what do you pass it? A standard numeric limits of a standard stream size. You basically say, hey, create the maximum possible number, like whatever number an unsigned long caps out at, like 16 quadrillion or something. That is how many elements are in the array. Only then would it not be out of range. And actually, it still would be out of range, because when we do underflow, we get the maximum number that an unsigned long can hold. But if we instead create an array with the maximum number that an unsigned int can hold, well, then the final index is that -1. So if we indexed it with n, but the final index is n-1, we still get undefined behavior because we're still 1 outside the bounds. And you think, okay, do another +1. Can't, because that's the most that an unsigned long can possibly hold. So if we do that, we're going to get undefined behavior. We're going to be accessing it out of bounds. So those are the two things. And apparently we're going to get into how to use signed values instead. There was something else. There was like a not a standard size t, but a standard something. It's like a, what is it? An SS size t, or it's like a 2 letters in a row. Fuck, I don't remember what it's called. But it's the opposite of it's the signed counterpart to a size t. And we could use that, because then when we're decrementing, we're saying while something is greater than 0, well, eventually we're going to get -1, and then it's going to stop the loop instead of doing underflow. So I could see that there could be some signed solutions here. So 1, the loop keeps happening, and 2, we're also getting undefined behavior. And we can be careful about using our values, and we can maybe have other checks to make sure that, hey, if the value is ever this big, then it's underflow and don't execute. In that case, you could just say when it's greater than 1, and then when you decrement to 1 or decrement to 0, then you're fine, because you see, oh shit, now it's 0. 0 is not greater than 1. Okay. So there are ways of doing it, but each one of them has its own specific, it's just its own little trick. Like in calculus, you learned the, what is it, the shell rule, or what is it, the shell, what was it even called? The shell method. all these little tricks to calculate something in a specific way or get around a certain thing. It'd be cool if we could restructure this with a better overall solution that works, like some other type that exists. Like instead of saying, oh, I'm going to create a bunch of different variables that would work as an array, but I don't know that arrays exist. I'm just going to name them hand 1, card 1, hand 1, card 2, hand 1, card 3, etc. Boom, array is the solution. So what's our solution here? Using a signed type for a loop variable. Also has its own issues. So in this case, we have an array. We're printing the reverse of the array. We're trying to count down and print 9, 1, 2, 8, 3, 7, 6, 4. Okay. Okay, taking a constant array that's unchangeable. Taking, oh, so it's just the opposite. So instead of just defining a standard size t here, bro, what? Oh, because we're getting the final index. So yeah, it's just the array size minus 1. Then we're casting it to be an int, just to initialize an int, just to use that int, and have to cast it back. Bro, this is even worse. 2 casts. We're holding it as an int, so this guy needs to be indexed with an unsigned int, a size t, which is an unsigned int. We may as well just keep the index the size minus 1. I mean, but we have to static cast in this. Oh, this is just ass. Calculate the average or something. Isn't this the same? We're taking a constant vector, or a vector that we're treating as const. Yep, we're getting the length of the whole thing, which is static casted from an unsigned int, which is the size of type size t, casted to an int. We then use the length, static casted back. Again, we're still just storing stuff as an int when it would just be easier to, like, we may as well just initialize index with this guy, or for 0 and then less than this. This static cast and all this is just unnecessary. And then we could leave the unsigned as here already. Excuse me. Yeah. You will likely encounter all of these in code written by others. Nice. Oh, but the problem is that we can't say greater than 0, because if it's greater than 0, we won't use the 0th index. I mean, we could say, well, it's greater than 0, and then actually index it with that minus 1. So then once it gets down to 1, it is minus 0. And if we start it at size, we're still indexing it at minus 1. But still. Okay. Yep. Yeah, also true. And that's what I was doing earlier. We're talking about different iterators. Standard size type. Oh, fuck. We have to actually get that from standard vector because it's what? Is this a static? Or yeah. It's either public or it's... Mm. Right now I'm not even sure if it's a public definition or if it's just a... Well, it's a type. I guess it has to be public. Okay. Because it's nested, we have to say which type we're actually using, meaning which type def are we actually, or which class definition are we using it inside. I mean, we're adding in an entire template just to be used there. Well, I mean, I guess we're already using it for that function, really. And we could just match it. Hey, if we're taking this array, well, we're going to just pass, or we're going to use the size type from an array of the same type. A dependent name. Oh, so the name... Meaning dependent names or template parameter names, basically? Or we're saying that in order to, if we have to, if in using something I'm required to list out the type, the template will hold. That depends on the type of the template parameter. Or well, hold on. Of the template type, meaning like it depends on whether it's an int or a float or a double. So type with a template parameter. That nested type is dependent because it depends on standard vector t. Well, yeah, and that's because t is being used. So anything that is used, or anything that we use that depends on a template name is called a dependent name. Okay. the declared type which returns the type of its parameter. Oh, because if we say what's the type of an array, it's a standard vector int. Gotcha. Yep. But if it's a reference type because it's a reference, we can't do declare type of a reference, I guess? Why? Because otherwise it would return a reference type? What the fuck? Pattern standard remove reference T. Remove reference from the declared type from the array, and the array is passed by reference. Meaning that the declared type won't work when we're pulling in a reference from something. So the point is we're removing the reference in order to actually use declared types, size type. Yeah, I agree. It seems so annoying though. We have to pick a sign type. Well, I guess we have to pick a sign type and initialize it with the unsigned size, which so we probably have to static cast. And then we have to use, let's see. Yeah, so we have to get the size, the length of the array is the signed value to initialize it. So we're going to cast it, and then we're going to cast it back. Oh, double cast bullshit again. I mean, sure, maybe. Okay. I get a little bit of music. Well, we know it's just a. Yeah, but isn't this a case that you made? Who gives a shit what type of array? We know that the size returns a standard size t, or size type. -1 gives us the maximum index. And then we just convert that to our signed type. Pointer diff t. Like, right? Are we thinking this? Excuse me. Oh. Or we could say and we actually want to do greater than or equal to 0. Why don't I just like that? Okay. In this case, we just know that, hey, this is the max index. Convert it to this guy, boom, and then we could do auto, but or you could just make it a standard point. Like, I don't know. If you're converting it to this, why not just have the type be this instead of define? Like, it seems like auto isn't getting you much bang for your buck. If I see auto, I kind of want to know what it is. Oh, I see it's being static casted. Oh. Yeah, I don't know about that. Yeah, it makes sense. We have an array. We're getting the final index, casting it to our index type, which is a signed value. While the index is greater than or equal to 0, because we're starting at the final index, we then decrement the index. Okay, so what are we actually doing before we decrement? We are printing the array, but we're casting the to an unsigned type, the signed type. Yeah, I guess we could say that, right? We could say that the length is equal to an auto length, or you could say an index length. If we're already using index, then why not just make it be index? I don't know. I mean, you have to change it anyway. Makes sense, because int's default assigned, and in this case we have assigned int. Boom, we can decrement, and it won't go below 0. Or at least it'll detect when it goes below 0, because once it goes -1, it will stop. Oh, standard S size. S size. Signed size. Gotcha. So instead of doing size, standard size this, or this dot size, we can do S size this minus 1 the whole thing. That gets rid of one cast. Okay. Fuck. Fuck. Fuck, I knew it. I prefer counting up. Oh, nice, and it returns a pointer to T. Cool. Well, cast it with nothing. Yeah, it needs an expression, brother. Cool. Oops. Cool. Converting the signed loop variable. I mean, it seems like we just cast her up, huh? No, not liked videos, bro. Let's do. That'll work. Oh, that one was kind of going. Dementory is pretty good right now. Let's do here. That's pretty good. So listening to this at work for a sec. Cool. Let's go. I mean, one's that really a conversion function? And so what, we're just converting to an unsigned, really? As unsigned? Get as unsigned or get unsigned? Convert to unsigned? As unsigned? I like as unsigned kind of. Please. Hold first, explain why I'm doing what I'm doing. Excuse me. Yeah, we need to pass in the pointer diff here, because if we do an int and we pass in a pointer diff, we get a narrowing. Because the pointer diff can't fit inside an int, because the pointer diff is a 64-bit big boy. No! Oh my shortcuts. What do we want? I mean, I don't really have any issues with pointer diff. Fuck, but this needs to be wall hold. Oh wait, but vector.size. When we were doing greater than 0, then we had signed initialized with a signed value. Oh no. What if we just did that? Sure, what about this? Still works. This is gonna be, it's gonna get made, it's gonna be converted to unsigned. I wish it said what it would return. Hold. Is returning a standard vector? Oh, it's returning a size type. There it is. I see it right there. Okay. Oh, here we go. Fuck, but this is... I also need as unsigned. I also need this as signed. Oh, this is kind of terrible too. Oh, this is horrific. Oh wait, duh, they have to be the same type. Oh, well, hold. Oh, because it needs a point, because that's why, okay, I forgot. I thought I put the point there, I missed. Because they were different types. Integer in the middle of two doubles. Hmm. I mean, we could do the same thing with as signed to make the array size, instead of a size type that's unsigned, it would be signed. Different ways of doing this. Alright, it's fine. I don't care that much. Yeah. I kind of like sign and unsign as the function names. Sign this, unsign that. We said z was the suffix earlier of a sign type, right? I think for C++ 23. You check to make sure that it's an integral first. Excuse me. We pass it a type for it to return, hey, is this type the same type? And then also to check if it's an enum, because if it's an unscoped enum, oh, well, I guess if we say that it's or, oh, we assert that one of these is true. Because if it is, then we don't care if it's an enum. But if it's not an integral, but it's an enum, I assume that only returns true whenever we pass it an unscoped enum. because those implicitly convert, but scopes do not, and scopes should return false. In that case, it would be false false if we pass it a scope denom value, which we shouldn't. Just handling a lot of stupid stuff, I think. And you're just cheesing it by using auto here. Yeah, I don't like that at all. That's so boring. It's readable, but it's a fucking pain in the ass. Okay, we have a class template. It's called signed array view. Takes a bunch of different things. So it takes the array of some type. Wow, it doesn't even need to be standard vector T. It can be any type array. It's a reference still. We have a function called signed array view. We have a constructor. It takes a reference, and we're initializing this current view there. This current view with that other array, which we're not doing as const, which is interesting. We're doing trailing? We're not even doing trailing. Okay. We're using auto to return the type that we're returning. Okay. And return an auto reference, so we're preserving the reference part. Well, allegedly. Trying to. So if we pass in a standard pointer diff, it's returning what? The array indexed with a size type instead? Gotcha. So we're basically saying we're creating a class. Why are we creating a whole class template? Hold. And so the point is we're getting an array, and then we're getting a view of that array. Well, I mean, really, we're just using copy initialization. Do we have to worry that there are any moves going on here? I guess not, because we're talking about a reference, so we don't have to worry about move semantics. Because then if the view ends up owning the whole thing, then we're screwed. And we're calling functions that return, or we're calling the subscript operator, or overloading it, so that when we pass it a standard pointer diff, it returns the index of that with a standard size type. Because we have to convert it in order to index it with this an unsigned, because we're passing an assigned. Okay. Oh, and we're also giving multiple overloads, so we can do it for an auto, we can do it for a const auto. Oh, and the point is so that if we're passing in a mutable array, we can do it for a mutable array too. Or we can treat it as const, which is why there's const right here. And then we also have ssize. Oh, we're not even using standard ssize, we're just doing ssize to return static casting it to be signed. We can create an array, we can create a view of the array, and then use the array in the view, which we can use in signed format. I'll do that. I'll copy that up top in a sec. Or I'll make that. Can index the data. So we could take an array, get an array size, or we'll store this as a length. It's a signed length. Have another signed guy. And say that while the index is greater than or equal to 0, we decrement it. And print the data with the index. We're using this in a function? No, we're not. Okay. Oh, and the points. So we could say, if we say, well, it's less than the size, or we could initialize it with the size. But aren't we? Oh, we're using ssize. Gotcha. Right? Aren't we doing ssize? That's the whole point here. No, we're not. We are actually doing a static cast. Okay. Well, I'll just do it this way instead. So we could do it signed mode, but we have to calculate it the other way, because if 0 is signed, we can compare our signed guy. Cool. But if we instead don't compare to 0 and we compare to underneath, if we start at 0 or start at the size, which way? If we start at the size and count down to 0, we can convert the size from unsigned to signed and then compare to 0. Cool, signed to signed. But if we start at 0 and are comparing a signed to an unsigned, then we would have to count. I think we can do it either way. And so he's static casting, but we could also just do as size of x. And then we say while index, well, and this should be -1 to be the final index. And while index is greater than or equal to 0. And we do size -1 because if it's capacity of 8, we don't want to index it with 8. We want to index it with 7. So if it's capacity 8, 7 being the final index and 0 being the first, 7 being the last. Okay, makes sense. And then we can decrement index. X data, and then pass it index. Or so the point here is we're saying that we have an array that needs to be of a certain type. Okay. Or well, really of any type, I guess, right? Do I want the using here or later? I don't know. Let me take a T reference array. And this needs to be a member array. Okay. And we could say using signed index. Oh, here we go. Need C standard declaration. Or hold on, wait. C standard definition. Concentration function that returns a what? Oh, I think we had an auto. And the point is we're returning a reference. We don't want to pass by value, so we want to return a reference to the element that we have. So, but a T is the type of array, so I guess that's why he's doing type deduction, huh? Instead of doing standard vector T, and then we could put T here, we could do auto, so sure, I guess so. I really don't like type deduction. Auto reference. And we're overloading that operator, the subscript operator. And it takes a Isn't taking, hold on, what is it taking? Oh, the point is it's taking assigned index. And it returns M array indexed with a static cast to a standard size t index. Hold. Okay, we just don't have a main yet. It's fine. Hello? Excuse me. And then we also have a const expression. Const. Excuse me, auto reference. So we treat it as unmodifiable. Or actually, we don't even do that. Auto reference. Well, I guess we could also keep, I think we might also need that. I'm not sure. Operator, this guy again. And now we take, just to handle both cases. Wait, so why do we, oh, so if we want to change, what is the point of doing both? Why not just do the one? I'm just gonna do this again. Our member array, and it's indexed with a static cast to a standard size t, the unsigned counterpart of our index. Access mutable. Well, hold on. What is the point of us even having that? I'm not sure. And then what else could we do? So we could get array elements like this. What else are we even doing here? So then we can use it with some signed shit. We're doing any conversions? I don't remember. When he is doing an auto instead of having to go into the class, okay. And auto is the index. Oh, that's the point. So he's doing, wasn't it getting the size of it as a signed version? Oh, yeah, because we need, okay, signed array view. Oh, what if we can't even use it on here, right? We can't use dot size here because this is a different type. Pretty sure. Uh-oh. Oops. Oh, I just fucking misspelled it. Oh, great. Why was it cool with these? I don't know. Guess it just didn't care until it was actually calling that class. Oh, because it didn't get a call to create the class until we actually passed it one, a constructor call, which means it wasn't actually, I guess, fully checking this to see if it was valid. Interesting. Yeah, so if we did y dot, yeah, see, we don't have anything. All right, so we do need the size. And it returns an S index, or hold, yeah, to get the size. An S index, well, a const expression S index. And it's not modifying anything on the inside, so sure. And it's called size. And it takes a T array. All right, const T array. Or, well, it should just be this. There's no, it doesn't need an argument. Const return. Oh, fuck, hold. Do I need to cast it to even get the size? How is this working? I don't remember. And so the point here is we know that we're receiving an array, and I guess we just assume that we have that size works for it. Okay. Oh, because this will only work for ones that... Yeah, because it's not getting a conversion error, which it should, because this should be an unsigned, and this is assigned. But it's not actually being called yet. Okay. Return a static cast to a what? To an S index. What? M array dot size. And now we can say y dot size. Cool. Or to make sure that we know that it's unsigned or signed, sorry. We can do that. So we could say for what's the type? Technically, it's a signed array view. Uh-oh. Because this guy's public. Hold. I guess we can't even access it, huh? Oh, because we have to initialize it with X, and then we can do it, because otherwise it doesn't get a default value? How does that even work? I mean, do we need a default constructor? Oh, because it needs to be passed. Signed, it doesn't exist until it's actually called with an argument, so we have to make one and give it an initializer first. Okay. I mean, I guess you do auto, huh? I mean, it works, it's just a lot of headway first. It's a little funky, I don't know, it feels kind of bunk. Versus our other way. Fix that dependent name. Oh, wait, hold on. Oh, oops. It's just the wrong syntax. Hold. Oh, oops. Hold. Oh. Yeah, we can't convert a fucking pointer, a function pointer. No, sir. Oh, can't convert from literally an overloaded function. That is the type. Because size is indeed an overload. Well, I mean, I guess it's an overloaded function. I imagine there's probably multiple sizes that we could get depending on what type of vector we're actually using. But how is it overloaded though if the arguments never change? It's always just an implicit this pointer, right? I don't know. Maybe it's a default argument. Oh, whoops, it's -1. We're accessing. We were getting undefined behavior there. There it is. Because we were accessing one beyond the bounds. And so he uses type deduction. Well, I guess you could do it either way, huh? So you could say, what is the length? The length is the length of the array. So you could say, and the point is to put length there just to substitute it so that it's shorter. Seems like it, right? And we know what type it is. It's a standard size t, right? Length. And we're initializing it with static cast to a standard size t. What are we doing? Vector.size. And so in this case, we're just doing length. Hold. What the fuck is happening here? Hold. Oh, oops. Because there's no function going on. It didn't know what to do with the parenthesis. In this case. Oh, I guess we do. We are still static casting. Never mind. But instead of this,
We're still static casting, but instead of doing vector size, wait, why are we doing length to be? Wait, there's no point of the conversion. It may as well just be the size. Why would we do that? Oh, because we're getting it as an unsigned. Okay. The point is that he's using this index type somewhere, but it's fucking hidden. Why wouldn't you just include that somewhere? Okay, that's annoying. Using index as standard pointer diff t. Sure. Then we can say index length is, and really it should be like signed length, but whatever. Length in this case is, hold. And now we can just call this index. Why the fuck? This should just be index as well. If you're going to use the type here to say that this is the type of an index, you may as well use index, index, index here instead of auto. You're going to have to change it anyways. It's just adding ambiguity. Like in this case, we're static casting to an index. What? Vector.size. And now we're just initializing index with length minus 1. Alias to signed, big signed int, signed length of vector, and then we can access vector with signed index. Initializing this guy with length minus 1. We're doing greater than or equal to 0, and we're counting down. Cool. Or, while it is less than, we could also just say index is nothing, and while this is less than length. Oh, fuck. We were totally decrementing. Whoops. It's already less. It's always going to be less. What was the issue? Ill-defined for loop? How do we mean? What do we mean? What are you bitching about syntax like this? No. It is ill-defined. Apparently not. Okay. We can use the data to use the signed version, and then we can just make the stuff nice by putting it outside the loop. Sure. That way it's like, hey, you're reading point A to point B to do a big C. Instead of A and B, you have to figure out in the middle of C. But it's really C, A, and B. We can use signed loop variables and indices. Well, that's just not true. You have a type alias right here. Yeah, dummy. We can see that you're using it. Well, oh, wait, or is it actually just a type called index? It's totally not a type, buddy. Hello? And in this case, we could just get the SS size, or the S size of the array. Okay, cooking and eating straight away after I get home is just the play, for sure. Cook and eat immediately, and then I have all this energy when I'm going. Oh my god, this is like the fight. Once this base kicks, I'm getting going hard. This is totally not true. We definitely have to do a type alias, but it's fine. True. True. Okay. So data doesn't hurt. All right. The only sane choice. Avoid indexing altogether. Hello? Avoid indexing with integral values all over. Other methods to travel through arrays that do not even use indices, huh? A range-based for loop. I've heard that term, and I've also heard an iterator. Oh fuck, we learn about iterators soon. Oh fuck, and we learn about a for each loop. Oh my god, we learn this next lesson. If you're only using the index variable to traverse the array, then prefer a method that doesn't even use an index? And it seems like index variable to traverse the array is like a common reason. But maybe not though, because if we're adding the index to it or something. But I think usually we don't. I don't know. Okay, avoid indexing with integral values to avoid these conversions. All because of some C++ mistakes that the developers made in the beginning. Unreal. What am I doing after this once this thing hits? Here it is. This is what I'm opening next. Okay, when is this kicking in? Wait. Oh, fuck. I forgot we start 4 minutes late. Whoops. Okay. An hour? Nice. I got time. Who is this? Cool. I want my piano to sound like this. I really wish it had that tone. Use a for loop to iterate through each element of an array using a loop variable as an index. Makes sense. In this case, we're just using an unsigned, and we're saying while it's less than the length, and we're incrementing it so that we're starting and counting up. I prefer that to counting down. The problem is when we count down, then decrementing, this wouldn't work. Prone to off by 1, okay. Yep. Traversing forwards. Another type of for loop. A for each loop. I've heard that Unreal Engine 5 for each loop inefficient. Removes unnecessary calls to the length. Repeated length calculation. Makes sense. Yeah, makes sense. I mean, the point of a for loop usually is just to go through each one. Maybe we just have a check each time to make sure that, hey, should we actually be here? Because for the for loop, we have a check in the condition to see whether we should continue. Well, actually, no, because we increment through it. Never mind. Ignore what I said. It's not right. It's not correct. And C style, cool. Range based. For element declaration. Through each element in array object. And for each iteration. Oh. So we go to index 0. Array's index of 0 is assigned to be the element, int num. So we say int num. This only works because the standard vector is an integer. But, I mean, it makes sense that it would be. Oh, okay. Okay, done for now. I'm gonna start doing some C++ in Unreal because I need to get the reps in so I can accomplish my dreams. And then in a year, hopefully working at a VR company. And then in like 3 to 5 years after, I've shipped some stuff, made some products and useful things. And hopefully that's enough to get the attention of, or at least to give me enough credibility to reach out to other VR places to collab and to people who are researching how to better simulate things in the mind so that we can simulate feeling so you can sit down in the game. Or at least other people making VR innovations. Long story short, I need to become a good VR game dev so I can collab with people who are working in, VR period, because I can't just magically get a PhD and go into VR research instantly. So, no, I'm not wasting fucking 4 more years of life, ain't no way. So, alright, next.